So let's solve this problem. So we are saying that a body weighing 700 Newton is suspended at point P by two inextensible strings at points M and T, where PM is equal to 1.5 meters, PT is equal to 2.0 meters, and MT is equal to 2.8 meters. If the body remains in equilibrium, calculate to three significant figures the tension in each string. Good, so we have to find the tension in each string. Good, so this is one of the questions under the topics you can get in the senior high elective mathematics. So let's quickly look at how we can solve this question. So for this one, we are going to do some sketches. Questions like this, you have to do sketches that will guide you. If you don't do sketches, you might find it very difficult to answer such questions. So let's do some sketches here. So we are saying that the body weighing what 700 Newton. So let's see, and then it is also suspended at what point P by two inextensible strings at points M and T. Good. So let's do some sketches so that we can identify point P, where point M and T will also go, and then we look at the measurements given in the question. At the end of the day, we are going to look at the tension. That's we are going to calculate the force applied in the strings. Okay. So let me begin by let's say we have this point P here. So let's say this is point P. Good. So let me indicate here P. Let me indicate here P. And we are saying that it is suspended at point P by two, but the body is weighing what? 700 Newton. So let's say this is our weight. Our weight. Our weight is equal to 700 Newton. So this is the weight of the body at point P. Now let's also look at the strengths. So the strengths, okay, the strength that suspends the body. So this is our strengths. So let me call this string. Let's say this is the first string. This is the first string. So let me call at a point M. So let me call this point M. And let me call this point also what? T. Good. So let's say this here. So let me join M to T. So let's take this as the roofing or the top where the strength is coming from, which hangs what? The body. Good. So we are talking about the tension, the force in each of the strings. So let me call this the first tension in the strings. Let me use F1 to represent the first tension, and then F2 because they are all forces. Yes, so I'm using F1 for the first tension and F2 for the second tension. Good. But in the question, it was given that PM is 1.5 meters. So let's see where PM is. So we know that this point is where the P is. So from P to M, we were given as what? 1.5 meters, right? Good. And also PT, so this is PT, was also given as what? 2.0 meters. Good, 2.0 meters. And again, MT is also given us, so that means from M to T, you can say that from M to T is also given us what? 2.8 meters. Good. So for such question, we have been able to do this sketch. Now let's look at the angles formed. So looking at this, you see that from PMT, it forms what? A triangle. Have you gotten that? So once it forms a triangle, then let's identify the angles. So one angle here, another angle here. Good. So we don't know the angles. So let me represent here as okay, let me call here angle A, angle B, and then angle C. Good. Now we can also trace a line from here to meet point P like this. Yes, to meet point P like this. Good. So once we have this trace of line here, now looking at this, because this is moving in parallel, so this line is parallel to this line, then we can see that this angle is alternate to this angle. So we can also call here C, angle C. The same thing here. This angle B is also alternate to what? This angle. So we can also call here what? Angle B. Good. So once we have this sketch, then we can move on. But note that once we have this trace of line here, then this particular angle here can also be what? 90 degrees. The same thing here can also be what? 90 degrees. Have we gotten that? So we have these angles. The reason why we have to identify all these angles is that at the end of the day, we are going to use the angles to help us find the tension in each of the strings. Have you gotten it? Good. That's why we have to know all these angles so that the whole work becomes so simple for us. Have you gotten that? Good. Now, for this question, you know that we can solve this question using three different methods. So we'll apply some of them here. So we can solve this question using the Lamy's theorem, what we call the Lamy's theorem. We can apply that. We can also use what we call triangle of forces. Triangle of forces is also one of the methods that can also be used to solve this particular question. Also, we can also apply the force sort approach. We can also use that to solve this. The force approach, that is the vector approach. So we can also use the vector approach to solve this question. So all these approaches can be used to solve this question, but we will stick to one. I think this one, the Lamy's theorem, will be used to solve this question to find the tension. Okay, so once we're able to sketch this, then let's quickly look at how we can find the angles. All right. Okay. So and we to find these angles too, we are going to use what we call the cosine rule. The cosine rule. So in a case where you have, let's say you have this triangle of forces. So let's say you have this triangle here. If you have this triangle here, so this is what triangle of forces. When you have three forces and they are what equilibrium at a point, then we can apply this approach. So let's say we have this one here, and then so we have these angles here. So let's call here, let's say we have here as A, and then we have this one as B, C. So let me use these angles to represent. So we have this angle here, we have this angle here. Good. So if you have a triangle of forces like this, when you have three forces, and so we can use this cosine rule. So to use this cosine rule to find the angles, this is how we go about it. So for this one, we can write a squared is equal to b squared plus c squared minus 2 BC, then cos, and then which angle is opposite to A. So we have this angle here, then we write that angle. So we are going to apply this here. The same thing applies here. If I want to get this, then it will be A squared plus C squared minus 2AC, then cos what B is opposite to this. So I will write that angle there. Then the last one, which is C. Good. So C is also equal to what? A squared plus B squared minus 2 AB cos. Then C is also opposite to this angle. So I'll write it there. So this is what we are going to use to solve this, or to look out for these angles. So we are going to follow the same thing. Have you gotten that? Good. So let's first solve for angle A. So angle A, if I want to get angle A, then I will look at the distance opposite to what? Angle A, which is what? 28 meters. So to be 28 all squared, 20, which is rather hot 2.8. Sorry. So this is 2.8, not 28, 2.8 meters. So I will use 2.8 squared here, which is equal to, then I will take the other measures. So we have 1.5 and then 2.0. So we have 1.5 squared plus 2.0 squared, then minus, so we have minus 2 times 1.5 and then 2.0, then cos what? So let's look at the 2.5, which angle is opposite. So it is angle what? A. Have you gotten that? Good. So if you use our calculator, then so 2.8 squared is giving us what? 7.84, 7.84, which is equal to, and then 1.5 will also give us what? 2.25 plus 4.0, which is equal to negative what? 6 cos A. Have you gotten that? Good. So if we do some simplification here, then we are getting cos A is equal to what? 1.59 divided by negative 6. Have you gotten that? So if we are to make A the subject, then we are getting cos inverse of negative 0.265. Have you gotten that? Which will give us what? A. So A is equal to 105.3 degrees. So I run out to two decimal places. I run out to two decimal places. Okay. All right. So that is for angle A in our sketch. Have you gotten that? Good. Now let's also look at which of the angles. So we can, since it is a triangle, we can solve for two angles using the cosine rule. Then after that, we can look out for the other angle by summing the two angles and subtract from what 180 degrees. Have you gotten that? Good. So that's what we're going to do. All right. So let's also find B, or let's find C. So after finding C, then we look for what angle B. So we apply the same what approach. So let me start from here. So angle C, let's look at the opposite what measure. So we have 1.5 squared is equal to 2.8 squared, 2.8 squared plus 2.0 squared minus 2, then 2.8, 2.0, 2.0 cos what? Cos C. Have you gotten that? Cos C. Yes. Because we are looking for this angle. Have you gotten that? All right. So let's continue. So if you use your calculator, so this one we are getting 2.25 is equal to 7.84 plus 4.0 minus 11 cos C. So to get everything, then we are getting cos C is equal to, so cos C is equal to what? 9.59 divided by 11. So when you take cos inverse, then we are getting C is equal to cos inverse of what? 9.59 divided by 11, which gives us what? So we are getting 29.33 degrees. So this one is also run out to two decimal places. Good. So once we are able to find angle A and angle C, then we can quickly find B by using this method. So B plus A plus C is equal to what? 180 degrees. We already know A and C. So we just write B is equal to what? 180 degrees minus. So A, we got 105.37 degrees plus, then C is also what? 29.33 degrees. Therefore, B gives us what? So when you sum all of them and subtract from 180, we are getting what? So we get 45.3 degrees. So these are our two, or these are our angles. Good. So once we are able to find the angles here, then we can do another sketch. So we can do our sketch here. So let's do our sketch here. Good. We can do our sketch here. Have you gotten that? So let me bring this trace of line here. So we know that this is our F1, which is first tension, and this is our F2, and then this is our weight. Have you gotten that? Where we already know as what? 700 Newton. Have you gotten that? Good. And so let's identify the angles we got here. So this angle A, we got what? 105.3. 37 degrees. And then we got this angle as well. So the B, remember here we got B. So B is what? 45.3 degrees. And then for C, we also got 29.33 degrees. Have you gotten that? We already know that here is 90 degrees. Here is also 90 degrees. Good. So we need to find the whole of this portion, So just 90 plus this and then 90 plus this. So if I'm to find 90 plus this, then what am I getting here? So 29.33 plus 90 is giving me what? 119.33 degrees. And 45.3 plus 90 is also giving me what? 135.3 degrees. Good. So once we know these angles here, we know this angle, So what we do is we are going to apply what we call theorem. Lame's theorem. So we are going to apply what? Lame's theorem here. Good. I'm going to apply Lame's theorem here. Good. So for Lame's theorem, whenever you have three forces in equilibrium at a point. So if you have this, three forces. So let's say F1, F2, and then F3, and then you have these angles here. So let's say we have this angle. We have this angle. If you have these three angles, then this Lame's theorem states that to find the tension or the forces, then we should use this. So F1 divided by what? Sine. So sine, which angle is opposite to F1? So it is this, sine this. This should be equal to F, what? F2. F2 divided by sine. So F2 is also opposite to this, and then should be equal to F3 sine what? So sine, so this F3 is also opposite to this. Have you gotten that? So if we have generalized that for Lame's theorem, we can apply this. Then looking at our question, our sketch here is similar to this. So we are going to apply the same here. Have you gotten that? Good. So if that is what we are saying, then we can quickly apply these ones. Okay. All right. So if we are applying this, then for this one, which is, so since I'm going to apply this, then I will have my F1 over what? Sine. So sine, my F1, it is opposite to this angle. So sine what? 119.33, which is equal to then F2 divided by, so F2 is also opposite to this angle. So sine 135.3, which is also equal to, then this is our W. Have you gotten that? So this is our W, which is already what? Which is already 700, Newton. So I'll write my 700 here divided by, and it is opposite to this angle. So sine 105.37. Good. So once we have this here, so we can pick one of this and equate to this and solve for F1. We can also pick one of this one and equate to this and solve for what? F2. Okay, so um let me quickly turn it. Let me turn my sheet, and then so we can now find our tension in each of the strings. So we have first one, which is F1, all divided by sine what? 119.33. So 119.33, which should be equal to, then we equate to the other part, which is 7 700 and sine what? 105.37. Good. So our F1, which is tension in the first range, is equal to, so 700 dot sine 119.33 divided by sine 105.37. So when you use your calculator, you are getting, so we are getting 637.9053305. But the question says we should leave our answer to three significant figures. So we can write F1, which is approximated to 630. So because it is three significant figures, so let's count 1, 2, 3. But after the 7 point, the number is greater than 4. So we add 1 to 7 to make 8. So we have this as this. So our the tension in the first range is given as what we got, was 638 Newton. Have we gotten that? So let's look at the tension in the second range. So it is F2 is divided by, so we have sine what? 135.3, which is equal to 700 divided by sine 105.37. Good. So our F2 becomes 700 dot sine 135.3, all divided by sine 105.37. So when you use your calculator too, you are getting 510.63966685, and it's also to be corrected to three significant figures. So let's count 1, 2, 3, but the last number is greater than 4. So we add 1 to this to get what? So we have F2 approximated to 511 Newton. Good. So the strength in these two, or the tension in these two strings, are 638 Newton and 511 Newton. So these are the two forces in the strings. Thank you.